Conservation of mass. This is an important chemical principle. Another way to state that is there is no new matter. All the atoms in the universe are all the atoms that are going to be in the universe, pretty much. So in a chemical reaction, matter is neither created nor destroyed. We say it is conserved in a chemical reaction. You can destroy matter in a nuclear reaction, but again, we're not talking about that right now. In a chemical reaction, any changes in mass are so incredibly small that we can ignore them. When we have physical and or chemical changes, the amount of mass, the total amount of matter doesn't change. And that was one of the things that Antoine Lavoisier was experimenting with, that he burned something in a sealed container and the mass didn't change. Sometimes, like if you burn a log in the fireplace, it appears that the mass of the log has changed, right? But that's because some of that has been converted, most of it actually, into carbon dioxide and water, which go up the chimney and are particles so small you can't see them. And so you don't actually realizing that a lot of that matter is disappearing up the chimney. It's not that it ceased to exist, but you lost it. You just can't weigh it anymore. So conservation of mass. If we burn 58 grams of butane in a lighter, it will react with 208 grams of oxygen, and it will form 176 grams of carbon dioxide and 90 grams of water. At this point, I am not asking you to figure these numbers out. I'm just telling you somebody did an experiment, and this is the amounts that they measured. What conservation of mass says is the total mass of the things that reacted in this chemical reaction was 266 grams, and the total mass of products, the things produced, is the same. In a chemical reaction, we don't have matter appearing or disappearing. It's like building with Lego blocks. You take one structure apart and you put the blocks together in a different way to make something new, but Lego blocks do not appear and disappear. They can't appear out of nowhere, and neither can matter. So this is the sort of question that could show up on an exam. And sometimes, actually a lot of times, students think way too hard about a question like this. This is just a concept question. This is not one that involves a lot of calculations. So suppose 12 grams of natural gas combines with 48 grams of oxygen in a flame. The chemical change produces 33 grams of carbon dioxide and how many grams of water? We have not learned how to write chemical formulas or balance chemical reactions yet, and we don't need to do it. So we can just use some words. So there was natural gas, there was 12 grams of that, and it combined with oxygen. It was 48 grams of oxygen. And that combined in a flame, and it produced, now we're talking about the products. We've got carbon dioxide. And what else is it making? Water. Well, they tell us how much carbon dioxide, 33 grams. And then they want to know how much water? 27. So how do we do that? Well, what's the total mass of your reactants? What you started with? 60 grams, right? 12 plus 48 equals 60. At least today it does. And so then this total mass must be 60 grams as well, because matter cannot be created or destroyed in a chemical reaction. So 60 minus 33 is 27 grams. 27 grams of water. Does that make sense?